I just started it. No problem.
You were able to start it?
I'm able to. But are you not on Nephio? Because I'm on Nephio. Oh, interesting.
Okay.
Yeah.
Great. Awesome. Yeah. Well, then perfect. Thank you, Stephen. Good. All right. Welcome, everybody. A couple of items. First thing, I just wanted a couple of updates. We had the TSC elected our vice chair, so congratulations to Tal, who's here. Anything you want to say, Tal?
You're on mute.
Oh, there I was on mute. Yeah, well, thank you for your vote of confidence. We had two people throwing their hat in the ring, myself and Wim Hendricks, and I think we're, these things are dubious honors. It's just a lot more work, volunteer stuff. I'm happy to do this because I care a lot about what Nephio is doing. I believe in what Nephio is doing, and I think I'm able to help move us forward. So that's what I want to do. So consider me your servant. And as for leadership and what that means, and if we can lead the project, in the end, we're all of us in here together. We're all leaders in a way of the industry, and I see that the roles of chairs here are not deciders, but rather facilitators. So that's going to be the style of chairmanship that I will add to the table. I did put 3 items that I thought we could talk about in terms of what I suggest moving forward. You can read them on the agenda here that's on the screen, but we can talk about that later. See, we have more items on the agenda coming in, so if there's time at the end, I can discuss them in more detail if there's any need.
Yeah, I'm sorry to interrupt, but we do have a hard stop at 9:30 for the ORAN people. So that's
excellent. So let's go forward with the next item then.
Okay, thank you. So that's introduction?
Yep, that's it. So go ahead, and it's up to you now.
Okay. My name is Antuvo. I'm a distinguished engineer from Marvell, focusing on enabling our data processing unit to participate in different cloud, edge, and core, as well as automotive, except I have a counterpart focusing on automotive, utilization, deployment, provisioning, and all that. I'll pass it to Thomas, please.
Thomas Fredberg, senior expert in Ericsson, mainly focusing on any type of platform infrastructure type of systems. And nowadays that means cloud infrastructure, all the way down from the hardware up through virtualization, software, and networking, and so on and so forth. I've been doing a bit of Anaket CNTT before, also part of ORAN specifications here as well. And we do have our own type of systems that we deliver all over the telco industry.
Udi, please. Udi, you're on mute. Okay, we'll come back to him then. Makaran, please. Introduce yourself.
Hi, I'm Makaran from Sankhya Labs. I take care of the standardization for the ORAN part from Sankhya.
Padma?
Hi, I'm Padma Sudarshan. I'm from VMware. I'm part of the telco architecture team and part of various standards organizations.
And then Tim Carey.
Tim Carey from Qualcomm. I work with the Qualcomm CTO organization for standards in ORAN.
Oh, Udi cannot unmute, but he is the Wind River, I assume, very senior architect, distinguished engineer, focusing on ORAN, especially Working Group 6, cloudification and orchestration. So next up is, I'm going to present the diagram slide that I have posted in the Slack. So let me share. Do I just?
Yeah, let me stop my sharing. I think you can just start presenting, but still.
Okay. Um, so originally, I posted this slide, and I was going to walk through the 9 steps in hot pink. But then after the discussion and demo and demo by John and discussion by Tal, I started incorporating their ideas into it. So I came up with this modified diagram, and it's not firm, it's not set in stone, it's work in progress, and I'm looking for feedback, suggestion, incorporation. This is a Marvell DPU service or workload provisioning deployment prototype. So it's not carved in stone, just to be clear upfront. I'm going to start with step 0, which is really John's work. So let's say Marvell or a vendor would publish a new software package, and we would go through the entire flow that John has suggested and get to the point where the software package has been reviewed, approved, backup. The software bill of material compliance check, the software itself, including source code, has been reviewed, approved, and has been put in, built and tested in staging, and it got to the point where it's in the deployment repo, main branches, meaning it's ready to go. And then we switch up to the human operator up here, and this is now edging into OPI and Marvell thinking. So, it's still fluid, flexible, but we're thinking that and it's also reflecting ORAN thinking, that we have different profiles, deployment profiles or request intent. And they could be categorized as networking profile, storage, security, and in the future, disaggregated memory pool using CXL. Anyway, the operator would express his or her intent by deploying one of these profiles. It'll go through the REST, a call to the API gateway server, and then it will go, the first thing it does after it gets here is it go to the orchestrator, right? Which is, I see it as an operator extending the kube API. We can debate about that. But once the service orchestrator has received the request, it checks for auth-n and auth-z authorization. It also checks with the inventory provisioning server to make sure that there is a matching image, container, VM, whatever, process even, binary libraries. And this, I may borrow some work from Cthulhu by Tal. I'm still exploring that. But let's say we found something that matched it, right? So the next step is, I seem to have missed my step 5 somewhere. Oh, over here. It would match, it will then fetch the blueprint, basically, and then match it against the configuration that OPI API is specifying. And that is specifically for network management, storage, security, and memory. Some of these are future, not defined yet, especially for memory and security. But anyway, we will match the blueprint, instantiate the blueprint, apply the network management service configuration in this case, and then we would push it down to the deployment, step 6A, to the XPU deployment admission controller. And this is where John gave me the idea that we could use feature gate so that when the package is handed off or reference sent to the admission controller, all it needs to know is, are the feature gate met? Yes, deploy, no, throw exception. It doesn't need to know the content, and therefore it becomes much lighter weight and more stateless, quote unquote. And 6A, happy path, we deploy it onto a DPU. And in the original diagram, sorry, oops. pardon me, hit the wrong button. In the original diagram, we have XPU from Intel and NVIDIA if we follow this pattern. So it's not particular to Marvell. But in this case, since I can't speak for NVIDIA and Intel, I'm focusing on Marvell. And if it's the unhappy path, which is 6B, then the service orchestrator would communicate that we need this new software blueprint package from to the configuration controller and the image build controller. And then it will go and fetch it from the deployment repo. So tying in John's demo of picking up where John demo and started, toward the end. And then from there, once we built it, we would register it in the inventory and provisioning server so that for future use references, and then we'll go down and deploy it in step 9. The original picture did not have the cluster separation, the light gray boxes. I added that and moved things around a bit to show the intent that the build cluster and the management cluster are in the control plane, right? And then the bifurcated workload cluster or worker cluster are in the data plane. My question to the audience is this admission controller, if I understand Tal's presentation correctly, we may have different admission controller per different type of cluster. I'm not sure, so I'll leave it. I'll end. One more thing. OPI has agreed to use Open Telemetry as the telemetry reporting mechanism. So that's why these OTel agent and OPI OTel collector are in here. This is the scope of what we're hoping to prototype within Marvell the next few months, and we have presented this to ORAN, OPI, and now Nephio. And I'll end my presentation here and let you guys jump in with question or ridicule.
No, sure. Thank you, Anne. That's great. Just a couple of things. I'll take the OTel one first. So Open Telemetry. So it's actually interesting because one of the things we haven't really talked about at all yet is as we distribute configuration to workload clusters, we want to get back a status of whether the intent is realized at the workload cluster. And my current thinking is similar to to piggyback on the metrics pipelines that are already there to get that back rather than implement another process for that. I think we probably will need to support multiple mechanisms for that, but that's kind of my shortcut. So the OTel thing makes sense to me.
Cool.
The piece that's a little bit different, or how I would think about it in the Nephio context a little bit differently, is so this admission controller. So you have it sort of sitting after the configuration, the package, the configuration associated with that application is already sort of complete. And more in my conception, at least, that complete package is already read by the, so there's no rest in my, so there's different ways to do this, right? If you look at Tal's presentation, he talks about how does the management cluster talk to the workload clusters. So there's two different ways you can do that. You can do that with an actual, there's probably many more than two, but two I'm going to talk about. One is you can actually have the ability for the management cluster to have connectivity directly to the API server running within that workload cluster. So that works. And it's a sort of centrally driven push architecture. And there are concerns and caveats with that, though, because that connectivity can be very difficult to achieve. Yes. And so the more typical, or at least I won't say typical, the way that I'm thinking about it as my de facto or sort of default case is instead that connection is considered is sort of a bootstrapping connection that's used one time to get the initial Git syncer, which is either config sync or Argo CD or whatever it is, up and running and configured on the workload cluster. And then from then on, the way we get workloads onto that is intermediated by the repository. So what this means is that you're reaching out to a Git repository rather than you're reaching from management and pushing in to the cluster.
Got it.
Then that's also why I want to leverage the metrics pipeline, because theoretically that already exists and is fairly robust and may use different networking channels than a reach in, because those edge clusters are typically not, you can't reach into them without a tunnel. And so I think any of these can work. It's just like, I think we need to support multiple ones. So that's one point. And so in that sense, like the deployment repo main branch sits sort of between your control and data planes. And so your admission controller, in my mind, would sit between the deployment repo draft branch and the deployment repo main branch. So those conditions, those package statuses and the like ready to deploy gate, those things sit before commit to the main branch. They sit between the draft branch. So we're iterating on a draft of the configuration over and over. And that's where I would then raise the flag of, okay, the image is all built and ready. Raise that flag there. And then you can actually then either have a human or an automated controller push that to the main branch, at which point it goes out to the workload cluster.
I have one question here. I mean, the admission controller is that is referred here in this presentation is the same thing as the admission controller as we know it in a Kubernetes cluster, like a normal one.
It's different. Dan.
It's different one. Okay, because that is a bit confusing.
Wait. I meant to take the admission controller and extend it, if possible, as a CRD or an operator that's supported. I haven't investigated that deeply.
Okay.
I'm hoping for feedback.
So and maybe Ravi wants to say something, but so what I would say is like admission controls sit in a particular place in the Kubernetes API pipeline. And while they're super important for many use cases, I think they're a relatively tricky extension point. And so unless they're strictly necessary, I prefer to avoid them.
Okay.
I would, but what you do have is, it's effectively conceptually, and I think this is the reason, right? Conceptually, it's the same thing. We're injecting what's effectively admission controls, but it's admission not to the Kube API server, but it's admission between the draft to the main branch of the deployment repo, but it's effectively conceptually the same thing.
Yeah, if I may jump in, one of the questions within the ORAN group we have is, and this diagram is not reflecting that, and nor what you just said, John. So I have to rework it and continue in Slack. But the question is, we were thinking of controller of controller, right? Because the management cluster may talk to different controller Kube API server for different workload cluster, ORAN cluster.
So on, if I may just very quickly, right? Let's not think of it in terms of layers, right? There's a lot of layering going on here, right? One things on top of each other. Maybe think of it as chaining. So rather than a controller of a controller, it's two operators chained. They're horizontal. I sometimes call it a side-by-side orchestration rather than top to bottom or bottom to top orchestration, right? So so they're friends. They're both equal. They might be running in different clusters, right? Depending on your bifurcation strategy, right? But the point is that they're one is not in charge of the other necessarily. And in some cases, if there's a disconnect, they can't even talk to each other if something fails, right? You know, this is part of what.
Yes.
Right? So they're all somewhat autonomous, right? Every operator knows to work with its own CRDs and its own resources, what it knows. If it doesn't get anything coming back in, it can still do stuff, right?
I
So that's a quick
Yeah.
comment.
Yeah.
I just want to
I
say we
just
have
had-
Ravi has been
Yeah.
waiting for a while with his hand up, so if he can please.
go,
let him-
go, Ravi.
Yeah, I think, yeah, sure. Hi, Ian. Yeah, just for completeness, I also participate in ORAN Working Group 6. So, yeah, so, I mean, I think that what is missing in this picture is that separation between the centralized management system, the functions that is basically part of that versus what happens in the edge cluster, and the pipeline that you showed. I think what John was also mentioning is the key package management aspects happens in the centralized management kind of system, right? Which is a Nephio cluster. But I think that management is primarily about kind of taking your service requirements and converting it into cluster requirements and your aspects related to network function orchestration, during which your actual your CNFs and the appropriate CNFs are chosen for orchestration, or basically appropriate manifests are chosen for orchestration, which is again kind of given to the edge clusters for deployment. So yeah, so I think that is one piece. I think somehow this diagram seems to be mixing up the two worlds.
Yes,
I think that,
yes.
yeah.
As I'm listening to this live feedback, I realize that this diagram is really a mix of core and edge, and I apologize. I will rework it to reflect.
Another related comment, and maybe this, I'm brainstorming with you here on.
Yeah, no worries, no offense. I'm taking all feedback.
No, this is great for thinking with, right? You know, obviously the scope of Nephio is not all of this, right? But it can show us how Nephio would work in an existing OSS environment, which is more declarative oriented, right? I'm noting, and I hope everybody is, that at the top here of the control plane is the Kubernetes API gateway. Everything underneath is considering to be running cloud natively in Kubernetes, which is great. I do want to point out, you put that dotted line between the control plane and the data plane, right? And then you put all the the worker clusters in the data plane. So I think about it it's a bit orthogonal for me here, because those kubelets running in the worker clusters are the control plane, right? They're part of the control plane.
Yeah.
So in a way, you know, I might turn this a little bit vertically. I'm not really sure how to do it, but the dotted line. So this again goes to my comment before about maybe a hierarchy and layering. You know, some of the separations are not so clear cut, right? So the control plane, I think, goes through a lot of this. A lot of these green rest lines are the control plane.
Yes, agree. I thought I understood your bifurcated orchestration, but apparently not. So maybe we can discuss in Slack some more. And John, the same thing with your control.
Well, I think it's close on both points. I mean, I think this is the evolution of the right. So
yeah,
we're all learning here, Anne.
No, I'm very happy. I told you guys, right? This is the best part of my day, is hanging out talking about this.
I wanted to comment on this controller of controllers versus chaining or peers. I think this is a really good point, and I some folks here have also talked about operators of operators, and it's rubbed me the wrong way, and I haven't been able to put my finger on it. So I appreciate that coming out. Part of the idea of the way the thing I talked about a while back in this sort of package conditions thing, I don't know if I actually covered that in my original demo. I think you and I talked about it and afterward. And so I probably need to do an updated presentation at some point that kind of covers it. But for those that, so maybe I'll cover it very briefly here. In Kubernetes in general, like if you look at the pod, for example, there's a certain set of things that have to happen to a pod in order to make it real. And in particular, when a pod's going to be part of a network service. And so, you know, you have to plumb the network, and you have to mount volumes, and you have to, you know, set up. There's so many things you have to do, right? And there's the solution. There was early on in Kubernetes days, there was a sort of life cycle for a pod, and they realized it was too inflexible. And so the solution that the community came up with is this idea of what we call conditions or status conditions on a pod. So this is a way, and we do the same thing with nodes. Nodes have node conditions. The idea is that you can raise these Boolean flags to indicate sort of whether a particular goal has been accomplished, and then controllers that can't proceed until that goal is accomplished can wait for those flags to raise. So in particular, there's something called a Readiness Gate that basically says when this set of conditions, and it's something you can set as part of the pod API, what the set of conditions is. You say when this set of conditions is met on the pod, then we go to ready, and then the endpoints controller actually waits typically for readiness in order to add it to the load balancing pool. So this is a way, just an analogy, or we're taking the same model. This is a way in Kubernetes where we've sort of demonstrated this concept of independent controllers, like kubelet, I think of as really a controller. It's just like it acts on a pod in a certain way. The scheduler acts on a pod in a certain way. CNI plugin, like all of these things have to get set up. And once all of those flags are raised, then we can proceed with the next step. So similarly, we can do that with a configuration bundle. We can say there's a certain set of flags that I'll have to raise to true before we're ready to proceed. And so that's kind of the idea there, and that's where it gates going from the draft branch. This is a package that's not fully configured yet, to going to the main branch. This is fully configured and ready to deploy.
Agree. Unfortunately, we have to drop for the 9:30 call in ORAN.
Oh, okay. I'm sorry. I didn't realize you had to go too. Okay.
Yeah. Thank you very much. I will post the notes I capture in Slack or in a file in Slack, and then we can continue the conversation there, if that's okay.
Sure. Absolutely.
Excellent.
Thank you, Ann.
Okay. Thank you. Have fun with the rest of the call. I have to drop.
Thanks.
Bye.
Thanks.
Have a good call.
Right. Thank you. So she has to go, but if I may, John, this started an interesting discussion. I just want to continue it a little bit.
Absolutely.
I mentioned, if anybody has experience with Argo workflows, it's also what it tries to do, what you described, this idea of gating, this conditional orchestration. But there's something a bit wrong about all of this, right? There's something, when you look at it, in an ideal, perfect world, everything will be declarative. You declare your intent, and there's some controller out there that is going to realize that intent. And it will know, it can realize that when things are ready, it doesn't always happen immediately, and it changes too, right? This is continuous reconciliation, right? So you expect in a cloud, which is a very ephemeral environment where things change, things fail and get recreated, that the status would change. Sometimes it's ready, sometimes it's not ready. This is healthy in Kubernetes. This is not considered, if a component is suddenly not ready, shouldn't be a huge disaster in the cloud world where everything fails. This should be something that works. So all this to say is that, there's things like Argo workflows, things like gating, things like conditional operators. Yes, sometimes they solve problems for us, but they're not really our ideal. It's a way to insert kind of an old school, the old workflow graphs that we're very used to, directed cyclical graphs, right, DAGs, from the kind of legacy lifecycle management world into Kubernetes. So they're great compromises. I think they're great solutions sometimes to solve problems exactly like this that get to be very hard. But in the back of my mind, I always see them as compromises rather than what we should really ideally be doing. Not to say we shouldn't use that again.
So I'm curious, there's a few comments, and obviously anybody else is welcome to check it. What do you see as the ideal? Because I see us as needing a mechanism to have collaboration between independent actors, which may be controllers or automated pieces of code, or actually even maybe humans. And I'm not sure. So this is, I think I see Bernard's on here. One of the things we talked about in the last call was this idea of defining the sort of framework for how these different pieces of automation will interact with one another. And the idea of status conditions, not a workflow that's linear. There's two. Well, okay, I don't go down too many rabbit holes at once. So I'm curious if you have other ideas for a mechanism for coordinating independent actors in a way that doesn't create dependency, so that we have that not even just chaining, but peer controllers.
Right. So yeah, anybody can jump into this. Is interesting, but going back to onside, and I hope she's not offended that we'll continue to discuss it here without her. But there are a lot of green REST lines, right, and API calls. Now API calls are temporal, right? Any API call happens at a given moment at some time, so you immediately have ordering, sequencing, and all the problems that get around with that, and what happens if the API call doesn't go. But in a declarative environment, we kind of want to declare everything at once. And, the operators, of course, there's a lot of lifecycle management behind the scenes to get it all work. There's always ordering there. But we shifted the buck, right? The ordering is done not, the designer doesn't have to care anymore about the ordering of things. The ordering should be figured out by the components knowing what they need to do, right? A kind of eventful consistency model. But I'll add that, yes, we have one big break here, which is the worker cluster might not exist yet. So we have this big temporal challenge, right? That's the bifurcation thing again, where until the workload cluster exists, you can't actually put all the declarations there. So you have this kind of one big limitation that we have to deal with. My hope is that we only focus on that temporal challenge and make sure that everything else won't be temporally entangled. But yeah, other people have their hands up. Yeah.
Well, I'll just respond quickly, and then Jean-Marie, I think, is the next one. Part of when you say everything should be declared up front, there's a bunch of decisions that have to go into what that declaration is. And that's what I'm hoping to automate with some of these conditions on the config, not on the runtime state, but on the config, so that we can resolve what the full declarative state is up front. But there's still, right, because there's different groups and different actors and different systems that we have to allocate things out of, it's still, it's a asynchronous concurrent set of processes.
All of this is asynchronous, right? An operator takes time until it actually generates the new intent, right? Some intent is coming in, it does something with it, when it generates something new.
Right.
And there's a propagation happening here, but this propagation is not something that the user designs, right, or even cares about. And also we take it into consideration that it can change even while you're working. You might be, yes, updating a custom resource while an operator is already trying to do something. Well, your expectation is that that operator would be continuously reconciling. So that change will again start to propagate, and eventually you'll get what you intended to get.
Eventual consistency.
Yeah, exactly.
Jean-Marie?
Yes, I agree. We need to absolutely avoid dealing with overall temporal dependencies, and they need to be managed independently by each operator and by each controller. And what we need to coordinate is what I would call the functional dependency at the intended state level.
So one question here. The getting it eventually. I know it's a basic Kubernetes philosophy. This is Bala from Red Hat again. So let's say we are not able to reach intended state for any reason. For example, a particular workload requires certain resources. Say, let's say it required a SRA VF, which is not available in any of the workload clusters at the moment. So it was just a trivial example. For a general question is, if the consensus or the state is not achievable for any reason, how far should the orchestration keep trying? I mean, would it give up at some point, or say, it's we are unable to reach it?
Yeah, one of the challenges I think of eventual state is, determining the state of the whole system, right? Because the whole system comprises right? Many components, some of might be in ready state, some might not be in ready state. How do you boil this up together into one thing? So this is the decomposition and recomposition that will be part of the architecture, right? I mean, these are very good questions about resiliency. And also we want to avoid loops, control loops, where you have, say, a component that's broken, says, oh, I'm not ready right now, and it tries to maybe self-correct. And then you'll have something that keeps self-correcting itself, right? We see these sometimes control loops when you have autonomous components. If they only handle what they're responsible for, they might think that they have to shift the responsibility onward when something is broken, and then you might get really circles, right? We see this actually in legacy orchestration systems too, where you have the DAG keeps going back and forth. Right, so yeah, we have to design these things carefully, and I think this is why something like what An did today is useful, because it helps us see like the real whole picture, right? The Nephio components will be part of a bigger picture, and we always have to keep that in mind. There's an OSS system on top, and if we keep telling the OSS system that we're wrong and it's going to correct, and we might get endless loops. So we do have to take that into consideration.
Yeah, that was the genesis of the question was, should we account for some kind of circuit breakers? So anyway, we'll talk about that.
I mean, I know Bernard wants to talk. I mean, I think a lot of us have some background in control loop and thinking all of this, what is a controller in the first place? This is computer science stuff, right? Engineering stuff. All of that knowledge is still important. I don't think declarative world erases all our knowledge from the past. We're still thinking about controls and signaling and all that. So we keep that in mind constantly.
Yeah, thank you. And sorry, Bernard, I spoke without raising my hand. Sorry.
Yes, please
No
go ahead.
problem. Yes. So I was just wondering if it would make sense to distinguish between pre-deployment related dependencies and post-deployment related dependencies. I was sort of basing this consideration on the comments from John when he sort of said there's a certain dependency management to be considered before you actually sort of hand it over to the automation, and after that there's certain sort of reconciliation mechanisms to be sort of thought of after the whole thing has been deployed. And I was wanting to ideally try to categorize those dependencies and categorize the way of how we handle those elements. So that would be one consideration I would love to see, because otherwise there's so many things which we could think of and so many different use cases. If we don't categorize them to some degree, it will always be guessworking from a telco operator perspective to understand why did this operator trigger some other thing, and then bringing that into a context is going to be difficult from an end-to-end perspective view. What I wanted to also mention is that describing the intent can be cumbersome if you have to be the Leonardo da Vinci of all the network functions infrastructures. Yeah, that means ideally we should try to be able to cascade the dependency management to local knowledge of operators or controllers, which can cascade the configuration management and sort of runtime handling and notifications needed between different operators. So ideally, from a tech operator perspective, we wouldn't want to sort of have to specify sort of on the top level the thousands of parameters which are needed in order to configure all the different network functions sort of which are constituting a solution.
Yeah, thank you, Bernard. That's I couldn't agree more. I mean, on your taking your second point first, like the strategy, I believe is, you can't be in a position where all your orchestration does is bubble up every single parameter all the way to the top. You're just creating a nightmare. The strategy would be, or that at least I have in mind, is that when we express sort of high level intent, we have the ability to, at a lower level, specify all those parameters, but then sort of give it a higher level summary view. So like a bronze, silver, gold, right, level service. So you've packaged a bunch of details into a single label. So at the high level, you can sort of just say, I want bronze, silver, or gold. Of course, it's a different price point or whatever it is with that. And that packaging into those groupings, can be done by designers or whoever with a different, to meet different customer requirements. But sort of at the very high level, you don't necessarily need to know all those details. It cascades down, I think, is the word you used. The second thing I wanted to comment on was your first point, which is in one of the previous discussions, I talked about sort of the stages in the life cycle of a configuration package and how it gets from sort of the abstract version all the way to being deployed on some cluster. And then even post-deployment, there's what we would call runtime. And that operators, and this is kind of comes also out of Tal's, is illustrated in Tal's presentation about the bifurcated control. Operators that run in the workload clusters take effect. Their actions, they talk directly to the Kubernetes API server, and their actions take effect immediately, and they are, relatively speaking, and they're what I would call runtime. That's at the runtime layer. So we also have a stage where we're preparing the configuration, and we want, and this is what happens in the management cluster. In Tal's terminology, there's the bifurcated control in the management cluster and in the workload clusters. What happens in the management cluster is operations on this configuration, and there's a set of dependencies that are sort of a priori knowable at that stage, and then the ones that are, we want to handle at that stage where we are not yet affecting the live operational state of the workloads. And then there's a separate category of dependencies, as you're saying, that are runtime dependencies. There's a dependency on allocations that happen locally within the workload cluster, or other network functions running locally in the workload cluster. Nephio scope would reach into those mechanisms by which potentially those operators should interact, and those dependencies there. And then there's even another layer, which is sort of protocol level, right? So once you've configured HSRP on 2 Cisco routers, you're out of the loop, and the applications themselves are going to manage that failover in that situation, for example. So there's like different tiers of dependencies. There's a dependency down there, but we don't care beyond the configuration level on that one. So we have to kind of categorize those all, decide which are in scope, and develop the best practices around where those dependencies should be addressed. That's kind of a big goal for me anyway with the community.
Yeah, this is all good. I'll add one more point. Another thing we need to consider when we design these interdependencies or design ways to handle these interdependencies that already exist is whether we want to think of it in terms of pulling or pushing. So one model could be that I update my status, right? The operator knows that something happened. Now I update my status. My status might have IP addresses, might have port numbers, might have nicknames, whatever it needs to say, okay, I set up this component that I have, and now the data is there. Anybody who wants it can now come and take that, right? So that's a very common approach. Another approach is pull-based. That is, look, I have all this state, and I don't know what anybody needs necessarily. It might be a huge amount of state, right? This is actually the more familiar model we have where with netconf, right? Netconf is a database, essentially, right, for netconf to work. So every component has all the Yang 3GPP models, and it's there. If anybody wants that, query. Go there, ask that component, ask that switch what it has, and now you have that data, right? So I think both of these strategies might exist together, And I don't know what is best for any given scenario that we're going to deal with. But I'm just putting that in our mind as this is a decision sometimes we'll have to make. You know, are we putting the status there for everybody to take, or are we asking for, are we telling components to ask for us? There are pros and cons to each approach, I think.
So one of the things that makes me think, one of the things that comes up frequently is resource allocation in the workload clusters. And you need to make a decision in the management cluster about, say, placement. And so you need to make sure that availability of resources within that workload cluster. And there's sort of two different, just mirroring what you said, Tal. And I'd be curious about people's thoughts on this, right? There's two different ways to do that. One is you can sort of top-down control, say these are the resources that should be available. The other is you can bottom-up discover. So when the workload cluster joins the management cluster, there's some agent or whatever running there that's going to discover available resources and publish those up to the management cluster. And then there has to be some sort of reservation mechanism, or these I think are going to be some of the factors we have to figure out. And I don't necessarily have a full opinion on all of them yet. It kind of depends on maybe what comes out of group one as far as how the planning process works. And, right, at some point we could say, okay, our intent is this network function with this capacity. So we're actually going to provision nodes and clusters down there in order to support that, right? And that's one model. Another model is we have an existing set of infrastructure out there and we're going to schedule it onto it. I'm suspecting we're going to have to support all of these. Jean-Marie?
Yeah, I'm a bit confused because if we are really going intent-based, those dependencies should be expressed as intent. And why should we express and expose any status that is not related to an expressed intent? Because if nobody has expressed the intent to the requirement for such a thing, nobody cares about that thing. So why should I expose it?
Yeah, I mean, this is when you start building these things, that's where you find the problems, right? I think sometimes in order to declare your intent, you're missing some piece of information, right? I'll give a classic model of netconf, right?
Hold on. I would submit that if you're missing that piece of information, that piece is probably not intent.
Right, and this is where good architecture design is so important, right? Because if you designed your intent in such a way that it would already depend on something that might come later down, you already have a problem. Architecture is going to be so important here, right? Because exactly not to create those interdependency loops between resources. Yeah, I don't think it's trivial or easy at all, right? Declarative doesn't mean you're solving everything just by saying, I'll declare my intent. We have to model that intent very carefully.
Yes.
I know Bala has his hand up. We do have 4 minutes left. I was hoping we could take just some time to discuss what we're going to do in terms of future meetings and setting the agenda. Bala, is that okay? Just I want to make sure that we...
Yeah, that's fine, Tal. That's fine, yeah.
Thank you. Yeah, we can absolutely continue to discuss this in Slack on the SIG Automation channel. I think An was also saying she would happy to continue to discuss there. So I made the point, and John, we're co-chairs, tell me what you think, but for, I want, at least in this early stages of Nephio, to keep things pretty casual in terms of the agenda, but also at the same time, keep us moving forward. So I'll say this, anybody who wants to put anything on the agenda can, in my opinion. For next week, or if we have too much happening in 1 week, John and I as facilitators can move things around maybe just to make sure that there's enough room to discuss. But I don't think we're at the point where we're gatekeepers and everybody is a contributor. And in fact, I think I think everybody would agree that An's presentation today was very helpful in giving us something to discuss. More of these, if you have any kind of thought, I think all of us are brainstorming in our own teams, in our own companies, thinking about Nephio, what it can do for us, what it can do for the industry. Share it. If you can create some sort of rough presentation, even just a few slides or even a short document of a few paragraphs, I think that would be really great at this stage, just for all of us to discuss. At the same time, we don't want to get bogged down too much by philosophical discussions, which maybe we a little bit did today. I'm not sure everybody would agree. So this is why I put that note. Let's self-regulate. Let's just make sure that we're not overindulging in our pet issues that we care about very deeply, and make sure that the whole community goes forward. This is a note that I take for myself, because sometimes I talk too much and ramble. So I'm going to try to do that less and make sure that we're really doing things that are moving us forward as a group and not indulging in a specific little itch that people have, which could come up. It could come up in an agenda later. If that all makes sense to somebody, John, does that make sense to you as a way to kind of move?
I think that's great. I think that's definitely the stage we're at. And in general, I prefer these type of community meetings to be self-regulated agenda. Put your item on the agenda. As chairs, we'll sort of, if necessary, shuffle things. Jean Marie?
Yeah, maybe we want to put a deadline, like 20. Don't put anything in a shorter period than 24 hours before the meeting, so that there is at least a 24 hours opportunity to look at the agenda and think a bit about the new topics that have popped up.
I think that makes sense, and that way Tal and I, the night before or the morning of, or probably the night before, can prune the agenda. Vish?
Yeah, so when do you think you guys, I mean, Tal and John, of course, with the community, you'll have a plan to work on some deliverables. So are you thinking that the next 2 weeks will be open? I mean, I can see that already in the requirements, network architecture. I think Kaushik has got good vision in actually coming up with principles. I think that's a good thing, and I think he's still trying to work on that. I think maybe it needs to all map to what the requirements come in, or any POCs that you're working on that gets proved out, that we as a community can jump. If you have some proposals that you put in GitHub, we can all actually go either in Google Doc or in GitHub, that we're able to go off and provide our comments or understand what's going to go on. What do you think is a time frame? Like, do you think it's 2 weeks, or you still need to discuss that?
There's still work, we're still getting requirements, like we said, but we do have general ideas of pieces we're going to need. I'm working with upstream communities to develop some of the things I think we need. But it's a good question. And I definitely want to get very soon to the point where we've got sort of executable understanding of components we need to execute on. And Steven's working on some demos, but I think realistically, it's probably going to be, we should have some progress towards that in the next 2 weeks. And maybe in a month, we'll actually have things people can move independently forward on. I would hope sooner, and we'll try and make it happen sooner, but we're still getting so many requirements. There's just still a lot of formation going on.
Yeah. Okay. For me, I've been promising that for a long time, so hopefully I can show something.
So it seems like also some of the tooling that you guys talked about in the SIG automation, like, we're talking about config sync and some of these other things. So if there can actually be like 10-minute discussions, at some point of time, this is the community that's going to be reviewing some of your code. Some of those tools that you plan to use in Nephio are thinking about it. If there can be overviews given here, that will also be useful, is what I think.
Great idea. Yeah. Okay.
Thank you.
And I would add, we're out of time, but I'll add, let's get POCs not just from Google. I know I plan to do some, and I know some of us are working on stuff. Of course, not everybody is, Google is very open source focused. Red Hat, we're 100% open source. I know that not everybody here can share POCs that easily with the rest of the world, but I would encourage you to try at least. You can do something using open source components that we have a lot of, or even just null components, like basically what John did was using DNS or something that's not.
Sorry, guys, I'm getting kicked out of the room. I gotta go.
Okay. So yeah, that's also what I'm hoping to do, because I'm always a code first person. I'm far more excited when somebody shows a POC than showing slides.
Right.
So I'll try to do things, little things that might help demonstrate certain ideas that I have, and I would love to see the rest of the community do the same.
Yeah, I think also good. It will be great that, think about this as one on class for most of us. Not everybody might be. I don't want to make the assumption that everybody understands all Kubernetes concepts. So, spending a few minutes walking through those basics and then jumping in deep will be great. I think it will be a good way to get more of the members involved, is what I feel.
Yeah, exactly. So, yeah, as a remaining chair here, I want to respect everybody's time always and try to make sure that we end on time. So thank you, everybody, and we'll see you next meeting in 2 weeks. And
Yeah,
Stephen,
okay.
you'd be able to stop the
I'm going to stop recording. Yes.
Thank you so
Okay.
much.
Thanks, everyone.
I appreciate having you on.